40 light years from where you are listening, there lies a planet way out there in the cosmos. A planet that has the best chances to welcome human life one day. Meet TRAPPIST-1E and check out what your life would be like there. TRAPPIST-1E is a special member of an exclusive clan of 7 exoplanets in the constellation of Aquarius. From time immemorial, scientists have discovered more than 5,000 planets outside of our solar system, and some of them are in a star's Goldilocks zone, aka habitable zone. This is the region in which liquid water could exist on a planet's surface because of the perfect orbiting distance from its star. In this zone, the climate conditions are perfect to support water as a liquid and life as we know it here on Earth. Planets like these hold huge prospects for humanity's space colonization efforts. But what would the weather be like on TRAPPIST-1E? What kind of life could we sustain on the planet? And how is it different from any other exoplanets discovered so far? First, let's explore how this hidden gem was uncovered in this infinitely vast universe. As it turned out, astronomers found the exoplanet by using the transit method, in which the dimming effect that a planet causes as it crosses in front of its star is measured. Scientists observe an ultra-cool dwarf star called TRAPPIST-1 between 2015 and 2016, but eventually made their final discovery of the exoplanet in 2017 by the Spitzer Space Telescope. Among the 7 exoplanets in the star's system, TRAPPIST-1E has by far the best chance to host life and to be an Earth-like ocean planet. According to the Habitable Exoplanets catalog, this beautiful one is one of the most potentially habitable exoplanets ever to be discovered. So what if we lived on TRAPPIST-1E? Taking the unique circumstances into account, living on this exoplanet offers a different level of luxury than any of us are familiar with. The first reward you'd get if you were to live on TRAPPIST-1E is an undeniable access to the planet's amazing night sky views. Its neighboring 6 planets offer a spectacular view to be amazed about. And guess what? You wouldn't have to strain your eyes to get a good view of them. In some cases, the planets of the system might appear twice as big as the Moon when viewed from Earth. This is made possible because all 7 of the known planets in the TRAPPIST-1 system orbit closer to their star than Mercury is to the Sun. However, there is a bit of a problem here. Natural light on TRAPPIST-1E is reportedly very dim, but that is expected. Astronomers describe TRAPPIST-1 as an ultra-cool dwarf star of late M-type, meaning it produces significantly less radiation than Sun-like stars. Punctual data tells us that the exoplanet receives only about 60% of the sunlight that our Earth gets from the Sun. Also, most of the light emitted by the star is radiated in infrared rather than visible wavelengths, meaning the daytime skies on TRAPPIST-1E would barely get brighter than the Earth's skies around sunset, something like a salmon-colored sky. But not to worry, there is hope for relatively normal human life there. The exoplanet has almost the same size as Earth, only 500 kilometers smaller when it comes to radius. But it is very, very close to its parent star. The planet keeps 0.029 astronomical units from the dwarf star, meaning you can see it 4 times bigger from your backyard than we see the Sun from Earth. But more importantly, this closeness gives us what we need the most: heat. The calculated equilibrium temperature of the planet is around minus 27 degrees Celsius on average. Of course, that is far from a hot day in Miami Beach, but certainly better than the more hostile temperature of Mars, which is said to be around minus 60 degrees Celsius. For sure, a lot of efforts would be needed for humans to be able to grow vegetables on the planet and secure a long-term habitat. But the task is certainly manageable. All the more as TRAPPIST-1E is confirmed to be rocky and not have a cloud-free hydrogen-dominated atmosphere, which makes it likely to have a compact atmosphere like terrestrial planets in our solar system. With a little help of greenhouse gases, the average temperature of the planet could be much higher. In fact, with the mentioned above, our Earth would be cooler than TRAPPIST-1E. You would be facing similar conditions on the planet gravity-wise too. As TRAPPIST-1E has basically the same density as that of Earth, you would experience 93% of the gravity you feel right now. These conditions are more than good for the human body to remain healthy, and no gravity-making sci-fi gadget would be needed to ensure our stay on the planet. Just imagine you could easily ride your bike or do everyday training without any special equipment needed. As a jackpot, all of us would weigh a bit less without any effort. Not so bad, huh? But there is even more good news. As the host star of the planet is a red ultra-cool dwarf with only about 8% of the mass of the Sun, it has the possibility to remain stable for 12 trillion years, which is 1,000 times longer than our Sun's life. These conditions give us time to settle on TRAPPIST-1E and remain safe and sound for a very long time, as this dwarf star will be among the very last to die in the universe. However, all coins have two sides. Besides the mentioned above, you would have a very different life rhythm on the planet than you have here on Earth, as TRAPPIST-1E is tidally locked. One of its hemispheres is always facing its star, while the other hemisphere is doomed for eternal darkness. This fact is certainly reducing its habitability, but seems not fatal. Just think of the long months of darkness that the northern region suffers here on Earth. It's not a piece of cake, but absolutely manageable. It is very likely that only half of the planet would be inhabited, while the other half would remain empty or only used for scientific purposes at first. To make our stay comfortable, we would be living in houses that can give you absolute darkness to be able to get a good night's sleep. By the way, sleep, and even our circadian rhythm, would be 100% based upon planetary coordinated time. As there would be no star set or star rise, humanity living its everyday life would need precise timing to start and end their day in the eternal light. And the same applies to planetary calendars. Let us explain. As the exoplanet is very close to the dwarf star, its orbiting speed is incredibly fast. Only 146 hours or a little over 6 days needed for TRAPPIST-1E to do one full orbit, meaning that a year on the planet is less than a week. Of course, only if we measure it by Earth's time. Hence, it is most likely that the planet would have its own coordinated calendar to fit your life best there. It's clear that the incredible orbit period, which is 82 days shorter than Mercury's, comes at great cost. However, there is a possibility that you could even go for a swim on the exoplanet. It is very likely that TRAPPIST-1E did not lose all of its water during its formation phase. Today, it could be a water world, completely covered by a global ocean. In this case, it could have a climate very similar to Earth. Maybe one day, humanity living their life on the exoplanet can conclude, well, there is not so much difference between our home and their home. But until the James Webb Telescope provides us with the missing discoveries on the planet, this remains a dream.